All right, guys, so in this video, I'm gonna go ahead and teach you all how to interpret motion diagrams, how to convert them into a position versus time graph, and then how to transform that position versus time graph into a velocity versus time graph. So this is the stuff that we did today in class. I'm just going over it again because I know it probably confused a lot of you guys, and that's okay. But I'm making this video to go ahead and clear the air with some of these things. So go ahead, and if you're watching this, thank you for watching, first of all, but also thank you for putting the effort out to try and do well in this class, because I know it is pretty hard. So let's go ahead and start. If you see here, I already did some calculations, but I'm going to go ahead and run through them really quick. So this motion diagram, first of all, it shows us moving at a certain pace for a couple of meters. And as you can see, I tried to make these, as like I said, this is like a rough sketch, but I tried to make these have equal intervals of distance in between them. And then I made some bigger gaps over here and then some smaller ones as we move to the right. So the first thing I wanted to do, I noticed that if I were to see this graph just by itself for the first time, I would notice that I have sections of different gaps. So what I did was I went ahead and I labeled section 1 right here, because these are similar in spacing. Then section 2, where we get some bigger gaps over here, and then section 3, where we get some smaller gaps on this side. So now that I've made my sections, what I want to do is find how many meters I move per minute that's passing by. So each of these dots in your particle diagram, if you remember correctly how to interpret a particle diagram, represents 1 unit of time that passes by. In this case, I'm going to go ahead and use this as minutes, and I wrote seconds here and I made a mistake. I'm going to convert that to minutes right there. So I'm going to use each dot passing by as a single minute. So what I did was I wanted to see how many meters I traveled per minute, and for section 1, I went ahead and I saw that I traveled 2 meters in 1 minute. For here, the same thing. I go from 2 to 4, that's another 2 meters per minute, and then from 4 to 6, another 2 meters per minute. So I found for section 1 that I travel 2 meters per minute. For section 2, I went ahead and did the same thing, except now we have a little bit bigger of a gap over here. And I went from 6 to 10 meters in 1 minute. So I sped my pace up, and I traveled 4 meters per minute for section 2. For section 3, I slowed down significantly. As you can see, these are smaller gaps from the beginning and way smaller gaps from section 2, and I traveled 1 meter per minute right here. So how do we put this on a position versus time graph? So I kind of already went ahead and labeled a couple points. I tried to erase them so that I can redraw them, but you guys understand what I mean. So if we look at each of these points in the motion diagram, you should remember from today that that chart we did of X and Y coordinates, what we got from our motion diagram. We're going to do the same exact thing. So we're going to get each of these points, and we're going to make a coordinate for them, and we're going to graph them. So the first point we graph is the origin right here, which is 0, 0. That's the starting point. At time equals 0 seconds, we were at distance or displacement equal to 0 meters. Then I went ahead and at 1 minute, because each of these in between, each of these dots represent a minute passing. So in between 1 minute, I moved 2 meters. So I'm gonna go ahead and just plot that right here. 1 minute, as you can see, time is on the X, position is on the Y. This is the way it should always be. I'm gonna go ahead and put that point right here. And then at 4 meters, I was at 2 minutes. So I'm going to go ahead and put that point here. At 6 meters, 3 minutes had passed. And then we switch our pace, and I start going a little bit faster. And then from 6 meters, I go to 10 meters in 1 minute. So at minute number 4, I'm up here at 10 meters. Let me erase that and try to do a little bit more toward the 4. It's kind of hard when you don't have graph paper, but anyway, there we go. So let me just connect these dots right here just so you guys can see. Okay, now at 5 minutes, I moved to position 14. So now I'm up here, 5 minutes, 14, which is right here. So now I connected those dots. And then at 6 minutes, I was at, what was I at? Let me look. At 6 minutes, I was at 15. And then at 7 minutes, I was at 16. So you can see the changes in our slope in this graph. And it might be a little hard to see here just because this is a rough sketch. But if we go back to the motion diagram, you can clearly see those changes in the slope, right? So we have a certain slope right here. And then we have another slope over here. And then a smaller slope right there, a more shallow slope there. So when we transform this to this, you should have some similarities in between what was on your motion diagram and what is on your position versus time graph. Okay. So now I'm going to show you guys how to transform a position versus time graph to a velocity versus time graph. And again, we did this in class, but it is a little bit tricky, so that's why I'm making a video of it. So take a look at this position versus time graph that we have here. Clearly, I have 3 different segments, as you can see here. I have one with a positive slope, one with no slope, and one with a negative slope. So one of the things that the AP exam loves to ask you guys is describe the motion of the object. So this is something that you have to talk about in words. And if you remember from the content objectives that I stated at the beginning of the unit, one of the things that we wanted to be able to do by the end of this chapter was to be able to describe motion narratively, graphically, and mathematically. So this is the narrative part of it. This is what they want you to do. They want you to describe it in words. That's why it's one of the content objectives. And this is important. Like I told you guys, kinematics is anywhere from 10 to 16% on that AP exam. So let's go ahead and start describing the motion of the object. I'm gonna go and start with segment 1. So what we see going on here is we have a positive slope. And what that indicates is that we are moving in the positive direction. So we could either be moving to the right or upward. Okay, and we are moving to the right or upward at a pace of, sorry guys, I didn't label these. So we're just gonna do these in increments of 1 second. So on and so forth. Is gonna be 11, 12, 13. So what we have is for every second that we move 2 meters. So that's gonna make our slope 2. So we are moving in the positive direction at a rate of 2 meters per second. This is just for segment 1. Now for segment 2, we have a flat line. And what this flat line indicates is that we are staying in the same position, which is 8 meters. We are staying in that same position for all those seconds that pass by. So for 1, 2, 3, 4, 5, what I can write here is for 5 seconds, we remain at position X is equal to 8 meters. We do not move. Okay, now for the last section, we have a negative slope here. And it's really important to be able to understand the difference between a positive and negative slope, because the slope, or the direction of the slope, indicates what direction you're moving in. So we have a negative slope here. It's going downward. We're going to be moving in the negative direction. Either moving to the left or moving downward. And this is going to be at a rate of, let's see, we go from 8 to 4 in, let's see, one second. So that's going to be 4 meters per second. That's going to be the rate. So you either write 4 meters per second down or to the left, or we can simply put -4 meters per second, indicating that we're moving in a negative direction. So this is how you would describe the motion of the object narratively or in words. Now, what if we wanted to take this graph and transform it into a velocity versus time graph? So we did this today, and I'm going to go over it again. Here we have a blank velocity versus time graph. What I want to do, the goal is to somehow get this to be transformed into this. It's going to look a lot different. And if you've taken any calculus class, this may look a little familiar to you, because position is the derivative of velocity, or velocity is a derivative of position. Sorry. So what we're going to do is we're going to find the slope of each section here, because the slope is always equal to the velocity. And this is for a position versus time graph. Okay, so anytime you calculate the slope for a position versus time graph, it's always going to be equal to the velocity, all the time, every time, no matter what. So let's go ahead and transform it. So what we did is we already found our slope here. We said it was 2. For this section, the slope was 0. So this is going to be 2 meters per second. This is going to be 0 meters per second. We are not moving here, right? We have that same position. X is equal to 8, and we remain there for 5 seconds. And then we have a slope of -4 meters per second over here. So all you're going to do when you transform this is you're going to take these points and graph them against time. So the time does not change. So I'm going to go ahead and make 13 seconds on my velocity versus time graph, the same I did over here. And let me erase this because I'm not going to have enough space. And then we'll write time over here. Time in seconds. Okay, so for my first section, I went a positive 2 meters per second, and that went on for 1, 2, 3, 4 seconds. So for 4 seconds, I'm going to be up here at 2 meters per second. And I'm just going to draw a straight line just like that, indicating that I was moving at 2 meters per second for 4 seconds. Now, if I look back over here, from 4 seconds to 9 seconds, which is 5 seconds in between, I didn't have a slope. I wasn't moving. I was going 0 meters per second. So you're going to go right here to the y-intercept, and you're going to look at this section right here. So from 4 seconds to 9 seconds, we were going 0 meters per second right there. And you can't see this, I should have put in a different color, but that's how you were going to draw that on your graph. Now for the last section, we went a -4 meters per second for 1, 2, 3, 4 seconds until we got to 13. So I'm gonna go ahead and do that. 1, 2, 3, 4. Here is -4. And from 9 seconds to the end, to those 13 seconds, I went -4 meters per second. And I'm gonna go ahead and connect the dots here, just so you can see better what's going on. So here, we're going 2 meters per second. Here we're going 0 meters per second. And here we are going -4 meters per second. So as you will see later on, the slope of a velocity versus time graph is equal to the acceleration. You don't have to know that right now, but it is something that we will go over later. And I hope this video helped. If you have any questions, feel free to ask me in class whenever you want to. Anyway, there you guys go.